Theoretical recap. Linux permissions are expressed numerically using an octal, base 8, system. Each file or directory has 3 permission groups: owner, user, group, and others. Each group is assigned a value based on 3 binary bits: read, R equals 4, write, W equals 2, and execute, X equals 1. Adding these values together gives the octal digit for each group. For example, RWX equals 4 plus 2 plus 1 equals 7, RX equals 4 plus 0 plus 1 equals 5, and R equals 4 plus 0 plus 0 equals 4. The 2 most commonly used permission sets in secure Linux environments are 755 and 644. Chmod 755, RWXR XRX, means the owner can read, write, and execute, while the group and others can only read and execute, typical for directories and executable scripts. Chmod 644, RWRR, means the owner can read and write, while the group and others can only read, typical for configuration files and static content. A common mistake is applying 777 permissions out of convenience, which grants full access to everyone and opens serious security vulnerabilities. Another frequent error is confusing file and directory permissions. A directory needs execute permission for users to enter it, CD, even if they do not need to run any program inside it. Mini example. A web server's HTML files should be 644, readable by the server process, writable only by the owner, while the directories containing them should be 755, traversable by all, but not writable by the public. Internalizing this mental model is essential for any security-oriented Linux practitioner. Workshop brief. This workshop puts into direct practice the symbolic and numeric chmod concepts you have studied in previous lessons. You have already learned to read permission strings and apply symbolic chmod step by step. Now you will consolidate that knowledge by working exclusively with numeric, digital, notation, the format you will encounter most frequently in real DevSecOps and penetration testing environments. The expected duration for this workshop is 3 hours. You must submit your solution before the deadline expires. Your mission is to build and secure a realistic directory structure simulating a small web application deployment. You will create a set of files and directories, assign them appropriate numeric permissions reflecting real-world security best practices, verify the results, and document your reasoning. This is not a guided tutorial. You are expected to make decisions, justify them, and demonstrate that you understand the security implications of each permission choice. Step 1. Environment Setup. Begin by creating a working directory called webapp_permissions in your home directory. Inside it, create the following structure: a public_HTML directory containing an index.html file and a style.css file, a scripts directory containing a deploy.sh shell script and a backup.sh shell script, a config directory containing a db.conference file and an app.m file, and a logs directory containing an access.log file. Use the commands you already know, make, door, touch, to build this structure from scratch. Do not copy-paste a ready-made script. Building it manually reinforces the muscle memory needed in real environments. Step 2. Applying numeric permissions. Once the structure is in place, apply numeric chmod permissions to each element according to the following security logic. All directories must be traversable by the owner and the group but not writable by the group or others. All HTML and CSS files must be readable by everyone but writable only by the owner. All shell scripts must be executable by the owner and the group, but not by others, and writable only by the owner. Configuration and environment files, db.conference, app.env, must be readable and writable only by the owner. No access whatsoever for group or others. The log file must be writable by the owner and readable by the group, but completely inaccessible to others. Determine the correct octal value for each case yourself, apply it with chmod, and verify each result using LSL. Think carefully before acting. In a real security audit, a misconfigured config file can expose database credentials. Step 3. Verification and anomaly detection. Using LSL and stat commands, verify every permission you have set. Then deliberately introduce 2 intentional permission errors, for example, making db.conference world readable or giving the logs directory 777 permissions, and use the find command to detect files with overly permissive settings. Practice the following find invocations to simulate what a security auditor or a DevSecOps pipeline would do. Search for files with permissions 777, search for world writable files, and search for files readable by others in the config directory. Document what you find and explain in writing why each flagged permission is a security risk. Step 4. Ownership and the security link. Change the ownership of the scripts directory and its contents to a different user if your environment allows it. Use sudo if necessary, or simply simulate with chown on a test user. Observe how ownership interacts with the numeric permissions you have set. Reflect on this question. If deploy.sh has permissions 750 and is owned by a user that the web server process does not run as, can the web server execute it? Write a short paragraph, 5 to 10 sentences, explaining the relationship between ownership and numeric permissions in a deployment security context. Step 5. Deliverable and submission. Prepare your submission as a plain text or markdown file named chmod_report.md. It must include a tree view of your final directory structure. Use the tree command or reproduce it manually, a table listing each file and directory, the numeric permission you assigned, and a one-sentence justification for that choice. The output of your find commands showing the intentional errors and their correction, and your written reflection from step 4. Be concise but precise. Reviewers will assess not only whether your permissions are technically correct, but also whether your security reasoning is sound and professionally articulated. Submit your file before the deadline expires. Late submissions will not be evaluated. Advice for overcoming difficulties. If you are unsure about an octal value, convert it manually. Write out the 3 permission bits for each group, assign 4/2/1 values, sum them, and you have your digit. If you cannot switch users in your environment, focus on the permission bits themselves and simulate ownership scenarios in your written reflection. Do not hesitate to consult the man pages, man chmod, man find, man stat. Reading documentation is a core DevSecOps skill. You are allowed and encouraged to consult all previous lessons in this course and any relevant internet resources. You may work alone or seek help, but the final deliverable and the written justifications must reflect your own understanding.